Hello, this is section 2.1. So let's discuss whether things are functions or not. And if they're not, I'd like you to circle where they are, why they are not a function, where the problem happens. So I like to think of the inputs as, I like to do an analogy of times and places. And so the x's or inputs are the time, the hour, and the y's or outputs are like the floor or height that you're at. So at negative 2 hours from now, or so 2 hours ago, I was on the 0th level, so like right at the ground level. 1 hour ago I was up on the 5th floor. Right now I'm on the 6th floor. 1 hour into the future I'll be back on the ground level, and 2 hours into the future I'll be on the 3rd floor. So each time I know where I'm supposed to be. So this is a function, because a function has only one output for every single input. So now when I label x's hours and y's floor or height, I know where I'm supposed to be this whole time. Yes. Good. This is also a function. To test whether a graph is a function, we use the vertical line test. And so if I were to put a line, a vertical line here, if it ever crosses the graph more than once, at any point, at any time, then we have a problem that it is no longer a function. So let's see if I can grab this. Oh, bless you. Let's see if I can grab this vertical line. Well, let me move the graphs. So as I move the graph through this vertical line, notice that there is no point where the green line intersects our graph at more than one point. So this is a function. Whereas number 4, as I move this vertical line through the graph, oh, right there, notice it fails. At this time, the x is like negative 2.5. So 2.5 hours ago, I was supposed to be down here in the basement, way in the basement, and also up here. So it fails, so this graph is no longer a function. Now maybe you didn't draw your vertical line there, maybe you did it right there. It also fails there, and at several places through here. It just needs to fail once, like right there, or right there, or right there. When it fails once, it is not a function. And so I guess I would circle kind of this region. Hey, that's where our issues are, where we have more than one output for an input, and we say not a function. Not a function. Here, let's see. So let's play the time and space, time and place game. So here's my hours for inputs, and my outputs or y's are the floor. So 2 hours ago, I was 2 levels down. 1 hour ago was only 1 level below the ground. Right now, I am at ground level, and 1 hour from now, I'll be 1 level up, and 2 hours from now, I'll be 1 level up. And if you were to graph this, it would look something like this. And you'll notice that there are no points here that are on top of each other. There's nowhere that would fail the vertical line test, so this is a function. Now here, number 6 has a problem. Because 2 hours ago, when x is negative 2, my output is 4. 2 hours ago, I was supposed to be on the 4th floor. And then notice x is repeated here, and it has a different floor. So 2 hours ago, I was supposed to be on the negative 8th floor. So I was supposed to be on two different floors at the exact same time. And if I were to graph that, one would be right here, and one would be right there. I don't even care where the other points are, but I guess I'll put them in for the fun of it. That's the problem right here. This is this vertical line that when I draw hits these 2 points. So not a function for number 6. Oopsie daisy. Let's try graphing some lines. So each equation has a table that could go along with it that we're going to make, and then we could make a picture of that equation or the table by plotting those points on the graph. I'd encourage you to try some negative numbers and a 0 and a positive number. When I plug in -2, so let's try f of -2. So I'm going to substitute in negative 2 for x. And then when I crunch that out, I get negative 9. And when x is 0, 5 times 0 is 0, plus 1 is 1. So f of 0 is 1. And then when I put in 2 for x, 5 times 2 plus 1, I get 11. So negative 2 and negative 9, let's see, 2, 4, 6, 8. That'd be right about there, just off the graph. 0, 1 is right about there. And 211 would be up there. But notice these 3 red dots are basically in a line. Unfortunately, 2 of them are off the grid. So I probably should have done 1 or negative 1 and positive 1 instead. But there we are. This is a linear function, by the way, folks. And so you should find that the dots make a straight line. And that as long as you use a pattern with your x's, like I'm going up by 2's here, you should find a pattern with your y's, which I do. I'm actually increasing by 10 every time. I'm increasing by 10 every time my x changes by 2, which means the slope is 5. Coincidence? I think not. Here I'm pretty sure I'm going to start with negative 1, and then 0, and then 1, and then 2. So let's try f of negative 1. So plug in negative 1 for x. And you should get negative 13 there. Careful on your crunching. Use your calculator, I guess, if you're stuck, or show your work. There you get negative, it should be negative 10. Careful on my crunching. So we get negative 10, we get negative 7. And I knew that because I know there's a pattern with this, and then you've been through Algebra 1, perhaps you know the patterns. Here, 3 minus 7 is negative 4. That's a 4. And then I get negative 1. So remember, these are all coordinate pairs. So when x is negative 1, y is 10. Remember, this is your x-axis, and this is your y-axis. So negative 1 for x, negative 10 for y, like I said the first time. When x is 0, y is negative 7. So don't go left or right, go down 7. It should be right there. When x is 1, y is negative 4. So go right 1. So that's where x is 1, but go down to negative 4 for the y's. And to negative 1 looks like that. Boom. I'm going to go a little faster for the next couple here, folks. You would get, that'd be a positive 3, so you get negative 2, negative 5, negative 8. Should look like this. Whoa. You get the gist of it. Hit that dot. Here, you might want to do multiples of 3. Whatever your denominator is, it's going to be easier if you do multiples of 3, so negative 3 and positive 3. So f of negative 3, what that does is eliminates the fraction. I guess they wrote it differently. So negative 1/3 times negative 3 plus 1. So negative 1/3 times negative 3. If you need to multiply fractions straight across, do it. You get positive 1. So that equals 2. Plug in 0. That cancels out the fraction. And you're just left with positive 1. Now let's try f of 3. Here you get negative 3 over 3, which is negative 1, plus 1 is 0. So your graph should look like this. Find the value when x is negative 3, right? Because here, so decide whether the functions are linear or parabolic, and then find the indicated value of f of x. So first of all, this is linear because there's no exponent on the variable. And so what is y when x is negative 3? We'll plug in negative 3 for x. F of negative 3 is 4. This is parabolic because there's an x squared term in there. So 2 times negative 5 squared minus 20. So follow your order of operations. We have to do exponents first. So negative 5 squared is 25. Then we have to multiply next. We have 2 times 25, which is 50. And then we're subtracting 20, which is 30. So f of negative 5 equals 30. When x is negative 5, y is 30. This is a linear function because this is x raised to the power of 1. So that makes it a linear function. Even though there's a fraction there, don't panic. So we get 3/4 times, I'm going to just write this as 8 over 1 because that's the same as 8 getting substituted in for x. And then we subtract 1. So we get 24 over 4 minus 1. If anyone else to help me with that Google Drive thing, that'd be cool. So then this equals 6 minus 1, which is 5. So when x is 8, y is 5. I think that's it.